Welcome back and thank you for joining me. So, today we're going to talk still about factoring, but we're going to dive into a new method. So, our second method is something called factoring by grouping. And you use factoring by grouping when you have a cubic that has four terms, okay? A four-termed cubic. So, under that, I have listed the four steps. Okay, so whenever you're struggling, if you need to remember what do you need to do next, I want you to reference those steps there. Okay, so the first one is I'm going to group the first two terms with the last two terms. Okay, so I'm going to group them just like that. Group the first two and the last two. So when I do that, the second step is now I'm going to factor out the greatest common factor of both of them. Okay? So from both, so this first parenthesis right here, I can factor out an x squared. Okay? Because between an x cubed and an x squared, well, I can take out the lesser of those exponents. So I'm going to take out that x squared, and that's going to leave me with an x. It's going to drop the degree by 2 and a -3. In the second piece, 4x minus 12, well, hopefully you can see a 4 is going to pull out of that one. And I'm going to be left with x minus 3 again. So you factor each parenthesis individually. Then, once you've done that, now, ultimately, you should have the same things left in the parentheses. That's the only way factoring by grouping works, is if you have the same thing in those parentheses. And what you're going to do is you're going to write those as a single parenthesis. I'm going to pull those together out front. Then, these leftovers that I have that I factored out, those are going to make a second parenthesis. So factoring by grouping is essentially just a fancy way of getting two parentheses. Because now that I have those two parentheses, now I can use a zero product property to solve. So this piece right here, I think is easy to see. You get an x equals 3. Now this is something we haven't run into. All right? This is our first time factoring that we're left with a quadratic. And I don't have to continue factoring though, because notice, and we talked this way back in chapter 4, notice that I'm missing the x term in there. So I don't have to factor that thing. If I set it equal to 0, I can solve by square rooting. So when you factor by grouping, one piece is going to be linear, so you can just get that x equals 3. The quadratic piece, you want to set equal to 0, and now you want to solve by square rooting. What that means is I'm going to subtract the 4 over. Then when I square root both sides, we need to remember the plus and minus. And in this case, I'm square rooting a negative number. Remember, when you square root a negative number, you're getting an imaginary number. So square root of 4 is 2, and because of the negative, I'm getting the I. And there we go. So always remember, though, that quadratic piece needs to give you two answers. Remember that you need to get the plus and minus out of that quadratic piece. So let's take a look at how, in another example, this can work. So always the same process. When you have a four-termed polynomial, I'm going to group those first two and the last two together. Then I'm going to factor out independently from those pieces. So in this first group, again, notice an x squared is going to be able to pull out. I drop the degree of each piece by 2, which leaves me that. Then from that second parenthesis, the second parenthesis, a 5 can pull out. And the ultimate goal is that these should be the same. If they're not the same, it means you can't factor by grouping, or it just means you set it up wrong. Because everything I give you, where I'm telling you to factor by grouping, will be doable. So if it's not working out, basically that just means you factored out something wrong and you should try it again. But when you factor it out and you get those two parentheses, I'm going to pull that out front, so the x plus 2. Then those leftovers make up my second parenthesis. So once I factored by grouping appropriately, now I'm ready to solve with the zero product property. So this right here gives me an x of -2. That quadratic piece, remember, anything more complicated, I'm actually going to show myself setting it equal to 0. So I need to subtract the 5 over, so I can solve by square rooting. Now 5 does not get a nice square root, so always get the plus and minus. Because it's negative, I'm going to get an I, but there's nothing I can do with that 5. So I'm just going to be left with 5 still inside of the square root. And that's going to be it for that example. So again, not too horrible. It's just remembering the process as you're stepping through it, of grouping them, factoring independently, how to pull them together from there, just lots of steps. So sometimes though, when you factor or when you group them and try to factor out, sometimes something interesting is going to happen. So let's take a look at this. I'm going to group these, and I'm going to group those, the first two and the last two. Now look what happens. So here, as always, I can factor out the x squared, dropping the degree by 2. And here, I can factor out a 3. Now I want you to notice something. Here I don't have two same parentheses. I have x plus 5, and I have negative x minus 5. So sometimes when you pull it out, sometimes you get things that are oppositely signed. Notice those are perfectly opposite. X plus 5, negative x minus 5. Okay, perfectly opposite parentheses. What that means when you have opposite signs like that. And I'm going to backtrack, and what I should have pulled out was a -3. Okay, so next important lesson right now is signs matter. All right, so as you're going through, if you get opposite signs, pull out a negative with your number from that second parenthesis, and then you'll be set. Because now that I've pulled that negative out, now I have two of the same parenthesis. I can take my leftovers, so x squared minus 3. And now I'm ready to use a zero product property. So this piece gives me a -5. This piece, remember, I always actually set equal to 0 because it's more complicated. Add the 3 over. Now when I go to square root, I always get plus or minus. In this case, I'm square rooting a positive number, so I don't need to worry about imaginaries or anything. But square root of 3 is not nice, so I'm just going to leave it like that. So you can see just how important chapter 4 is with all these concepts, with knowing the plus and minus, knowing what to do with the square roots, knowing when you need I. So chapter 4 is critical to understanding this piece for chapter 5. All right, let's try it again. Oh, I'm sorry. There we go. All right, so from the first parenthesis, pulling out that x squared to drop the degree of each term by 2. And now the second parenthesis, if I pull out an 8, now notice, this is that situation again, okay? When I pull out that 8, I have two things that are oppositely signed. In fact, perfectly opposite from the first parenthesis, x minus 6 and negative x plus 6. So what that means is I should have taken out a negative with it. So if you see that right away, don't bother doing that wrong step like I do. When you notice that you can pull out a negative, I would say just do it. Okay, because it'll save you having to notice it and then erase it after the fact. So when you notice you can pull out a negative, seriously, just do it. Okay? And so now I have two oppositely signed things, or two correctly signed things. Two are the same. So I'm going to pull them together out front. I'm going to take those leftovers, bring them together. Then, of course, it still equals 0. So from here, now I'm ready for the zero product property. That piece gives me 6. That's our easy piece. Our more complex piece, of course, I'm going to write out. So I'm going to add 8 to the other side. And now square root. Always remember the plus or minus. Here I'm square rooting a positive number, so I don't have to worry about including imaginaries. It's going to be a real answer. However, square root of 8, that's going to be one that breaks down. Remember, I can simplify that by pulling out the 4. So my last little key here for you is when you can simplify, I still want you doing that too. It won't be too often, all right? However, when the situation does arise, I do really need you simplifying those expressions for me. Okay, so don't leave it as plus or minus square root of 8. Leave it as plus or minus 2 square roots of 2. All right, and that is our last problem for this one. So, as always, thank you for joining me. So, I know this was a new lesson, so what I want you to do in your summary is compare and contrast, all right? It'd be a good idea. Note when do I do things from yesterday's lesson versus when do I know to do things from today's lesson. That's going to be a very important skill because on your test, I'm just going to throw a bunch of refactoring at you and you're going to have to know which one to do. So I would highly advise in your summary, describe how to know when to use each one, what the difference is, so you can start building that skill before your test. So thank you for joining me, and make sure you come back ready to do your practice work.